Here is my anthro video essay. My voice might go, I'm like sick right now, but it's not, you can't really hear it right now. So it might go out a little bit. So I'm sorry about that. Okay. So there's a lot of discourse about evolution, and there's a lot of you hear a lot of things about how it's not real, or there's a lot of discourse. And I hope to better help you, because not you, but you know what I'm saying, help better understand why there's so much discourse about evolution. And to do that, we can look at how evolution really works, and that will explain the real relationship between humans and apes, because there's a lot of people that say things and they don't really understand what they're saying, and they have a lot of weird ideas, and then it spreads and it makes it hard for everybody to understand. And the reason why there's been such a push to label Darwin as this crazy lunatic who was anti-religion, an atheist, and then also talk about how evolution isn't this terrifying bad thing, and how it's good for our worlds, and it's a good thing to understand. So to start off, I'm going to talk about really just making it very clear what evolution really is, to better understand the relationship between humans and apes, because that's something that a lot of people often really mix up. So to start, I'm going to talk about natural selection, which is something that most everybody's heard of, but I'm just going to make it very clear what it is. So natural selection is I'm sorry. Natural selection is the process by which traits in a population are selected for due to environmental pressures, and I'll try to explain more clearly what that is. So there's a gene pool, right? And there's a population, and due to if it's hot or cold, rainy or not, certain traits that are in a gene pool are selected for because they are more advantageous. If you have those traits, you are more likely to have offspring, and that is called, okay, I don't have it here, it's somewhere. That's called, anyway, they're more likely to have offspring. I'm sure it will come to me in a second. So they're more likely to have offspring, and yeah, that's the whole idea. So you might ask, then, how do different species or different traits, if you look at an old human versus a new human, you'll notice that it's more than just some things are more prevalent and some things are less prevalent. And that's where modification comes in. So how do new genes become introduced? How does a new hair color or eye color come to be? And that is through mutation. I might have said modification before, but I meant mutation. That's through mutation. Basically, mutation is when inside a cell there is DNA. And this DNA, in order for the cell to reproduce, gets copied by a protein. This also happens when you have a kid. It takes your DNA is copied, and then it's turned into RNA, which is basically just half a strand of DNA, and then from the other parent, again, it's copied half a strand of DNA, and then they come together, and then you're half and half mom and dad. And that's how we see these generations where a parent is similar. Sequoia? No. It's my dog. No. A parent is similar to their child. So what happens when this protein isn't perfect? It kind of miscopies some of that DNA from parent to child. And that's when a mutation occurs, because there's a new gene, something gets switched up, and something new happens in the animal. And that's how new traits are introduced. And a lot of these times, these mutations are not advantageous. It will hurt an animal's reproductive success, but when it does, and it really helps the reproductive success, and it makes them way more likely to reproduce, then that gene will be seen more often in the gene pool than no longer. It will come and they'll be oh, this people has a lot of kids, and they have a lot of kids, so it will kind of take over the gene pool. because it's so advantageous. So yeah, that's how so there's mutations. And it's important to say that the variation in the population is through, that's allele variation, and that's in the DNA. There's alleles, and that's what's varied, and that's what makes the traits there or not there. And that's, so it descends and then it modifies. So that's why you see this like descent of traits, and some of the traits are modified. Either some genes are selected for more or less for, or a new trait is created only through mutation, and then it gets passed down. And it's important to remember that traits like hair color, if you dye your hair, only your DNA can be inherited. So you can't like get a nose job and it changes. You can't change your DNA during your life and have that. You can't change your DNA during your life, just period. So now I'm going to talk a little bit about why and how different species are created. Basically, so imagine that you have a population of a species, and for whatever reason, it's split into two populations, and normally this is just geographical. Okay, so it's split into two populations. There's different environmental pressures on each of these populations, okay? So if this one is in a really hot place, this one's in a really cold place, this one's going to select in the gene pool for traits that will help it survive and therefore reproduce in the colder environment, and this will select for, in the gene pool, traits that will help it survive in the cold population. So think about an animal with fur, and this is a hot place and this is a cold place. It splits up. This population is going to select animals with more fur, and this population is going to select animals with less fur. And that's really how it's called speciate. And yeah, it's if you think about it, it makes sense. And then after millions of years, this will change enough and this will change enough that they can no longer reproduce. And a species is simply two individuals that can reproduce and have fertile offspring. So they separate for long enough, they can't reproduce, can't have fertile offspring, aren't the same species anymore. So now I'm gonna move over and talk about why there's so much discourse. Wait, I forgot about talking about how humans and apes are related. That's my bad. Okay, so basically, humans and apes started out as the same species. This was the common ancestor, and it started in West Africa. And during this time, my last part was like basically all from the Shermer and lecture. It is like where I learned it. So in West Africa, there was this population of apes, and one went to one side of the African Rift Valley and one went to the other. And on one side there was a rainforest, and on one side there was desert. So they were pulled apart. They were no longer inter-reproducing. And on one side of this is the rainforest. So in the rainforest, you're still in Africa, but there's less sunlight. It's colder. Different traits were selected for. That's where we get apes. So apes have more fur because they were in a colder area with less like harsh sun exposure. And humans were in a warmer area where there was, where there was more sun exposure, so they had less hair because they were hotter. So they started out, they had the same genes, so that's why we are kind of similar to them. It was just different genes that were in this original gene pool that were selected for in the different areas. And there was a rift in between these two populations, and over millions and millions of years, they became different enough so that it could no longer inter-reproduce. That's why when people say, oh, why aren't apes descending into humans? It's not really what happened. Apes didn't turn into humans. We both had a common ancestor, and then we both changed. And that also, people will think, oh, but humans are more evolved than apes. That's not really the case. Humans are very good in their niche. They're very good in that desert environment, and to wherever they moved, they're good at modifying and like doing well, and so are apes. They're just as evolved for their niche. It's not like we're more evolved than them or they're turning into us. No, they're apes and we're humans, and we both came from the same place, but due to different environmental pressures, changed into different species. So I think that's a lot of times people won't explain that very well, and it gets really confusing. and then you don't understand it right, and it's not really your fault, but simply the person online that's telling you in a really weird way how it works. And then I'm going to talk a little bit about why there's so much. You'd be like, oh, but like if it was really real and evolution was real, like why is there so much discourse? Like why is this the thing that people pick on? And it's like, oh, it's not real. So I'm going to talk about why that was the case. And this is mostly from lecture. When Darwin was doing all this research, the people in power were in Europe, and they really relied on this idea of the great chain of being to like make themselves feel okay about what they did. So the great chain of being put humans at the very top of this chain, and not humans, God at the very top of the chain and rocks at the very bottom. But within this great chain of being, there were different levels for humans, and the idea was if you were at a higher level than the things below you, those things were put on Earth for you to utilize. So if you have white males up here, and then women and children, and then people of color, the white males were like, okay, that means we can use these people of color because they're not really human. They had this idea that they were greater beings. So when Darwin explained evolution, he really combats the idea of race, and that really then it combats the idea that there's different types of humans that are categorizable and that one is greater than the other. So the Catholic Church, which even if you are a religious person, you can agree that long ago it was corrupt. These people were in it for the money, and that's not a fault of God or whatever. That's just a fault of humans. And they were corrupt and they were in it for the money. And same with the people in power. If they admitted that, the reason that we have different skin colors and races across the world is not because we are greater beings, and just because there's different traits that are selected for in different climates, it really knocks the whole colonialism thing, because people knew that they were doing horrific things when they were colonizing, but it wasn't as easy for them to understand. They were like, oh, yeah, but they're not really human, so it's okay that we exploit them and do all this crazy stuff for them. But it made them really rich. They really liked thinking this way. So when Darwin was like, hey, this isn't real, race isn't real, it's just because we have these different skin colors because of where we're from, they really didn't like that, and it would make them not rich. So they really had a lot of smear campaigns that were like, oh, this is why this shouldn't be, here's reason A and B why he's not part of the church, and it's really reasons that don't make a lot of sense. They said that so he's not anti-religious. Actually, here, I need to open my other page notes. He initially studied at the University of Cambridge with the intention of becoming a cleric. That's Shermer. So he's not anti-religious. It's just the religious officials at the time really had a vested interest in his evolution not taking grip in the world. So they had a lot of smear campaigns against him. Oh my gosh, can't breathe. Okay, and then finally I'm going to talk about, I have to go back to the other ones. Talk about why understanding evolution is a good thing. So in order to understand evolution, we can look at things that mutate very quickly. And I know people think about evolution in this large time scale, but if we look at a lot of things, I'm forgetting which one, I think it's Thinking Like an Anthropologist. It has a lot of the modern ones, because this is where my notes from. I think that's the right one. In Thinking Like an Anthropologist, you think, okay, evolution is really long time scale. How would this ever affect my life, right? And that's really not the best way of thinking. We can see a lot of really fast changes in evolution where you will take a population here. This is an example from Thinking Like a Biologist. Basically, there was a species of fish, and this fish was moved into Lake Washington and another surrounding river. And then it was 10 years, these fish had changed enough in their mating rituals and to the point that where you put them together and they would not mate. So they had speciated in 10 years. And that's just like an example of how fast species can move and change. So yeah, it can happen super, super fast. And this can be hurtful sometimes. So think about things that have generations really, really quickly, like a virus or a bacteria. That they have like a 20-minute life cycle. These viruses can mutate the same way we do, and they can become more or less likely to reproduce. So if antibiotics are killing them and some aren't killed, those ones are going to reproduce, and those are the ones that are going to be passed on, and then they're going to be better at resisting the antibiotics and so forth. And then we have these large strains of diseases that can't be killed by antibiotics. It's like sitting in front of me. So you'd be like, oh, this is super scary. Like, I just don't even want to think about it. But it's not that bad. Most cases, this just comes from like a simple misuse of the bacteria. Bye, Kayla. That's my cousin. A misuse of the bacteria. So most of the times, these variations are not from just like, oh, like, but what can we do? And it's from misuses of antibiotics. So in poorer countries, a lot of people only use the amount of antibiotics. Oh, this is from Why You Should Learn Evolution. So in poorer countries, a lot of times antibiotics are used, but they're only used enough to get rid of the disease, like your effects of the disease on you, and not actually like get the disease from your body. So you're still carrying and able to give it to other people, but it also means that the only bacteria the antibiotics didn't kill are the strongest ones, the resistant ones, so you're helping them. And then in richer countries like the US, antibiotics are super, super overused. If you're not sick enough and you use antibiotics, you're just helping those stronger ones be more likely to survive and be more likely to reproduce, and when you spread it. So yeah, it's not that great for that. It helps us create drug resistance variants of viruses. It also, understanding evolution, though, if we understand evolution, we can understand how it works and how we can avoid disastrous things like that. It also helps us understand gene variations that can help us with like at-risk diseases. So we can understand how genes are passed down from parent to child, and you say, oh, your parent had this gene, like they do it in breast cancers. If your mom had breast cancer, like we know you're more likely for it. We can catch the breast cancer early. That's good, right? It helps you not get breast cancer. It also makes it's really hard to understand the natural world without pesticides. So it also can help economically in some ways. So if you are artificially selecting, so not by nature, but if you are killing certain animals for their hide or for their whatever, you are making the animals that normally wouldn't survive, like the runts of litters, more likely to reproduce because you're killing the ones that aren't the runts. So if you are fishing fish and you're like, oh, this fish is too small, you throw it back in, it has a higher chance of surviving. The fish is going to survive, and the fish altogether are going to become smaller. Because remember, those traits that are desired are selected for by nature because the other ones die earlier. So that's not great. So we want to make sure that we are like having the animals we want to see. So like economically, we have less of certain fish that are smaller. So it can help us, get some better hunting and fishing if you're a hunter fisher, is understanding how evolution works. So also we see a lot of evolution in the real world. We see penicillin, and then the first antibiotics are penicillin, and then the first resistance was seen in 1946. And then you'll see bugs and animals that show resistance to pesticides and herbicides. So it's important we understand where that comes from. I'm sorry for making this so long. I feel like I would miss parts if I didn't say anything. So overall, we can see how evolution really is just the apes, and I think that a lot of people, when they get really it's my I feel embarrassed I didn't know, but really there's so much discourse about evolution online. It's not really anyone's fault. if they don't understand it, or they're like resistant to it, because normally it's not a fault of their own and more of a fault of whoever explained it. They explained it wrong. They tried explaining apes from humans, and that's not really anyone's fault, and it's more just the explanation. So if someone was on the fence, I hope that this idea of like it's not your fault would help like make it clear, and then show like evidence, and then like just explain why this is pushed so forward, and maybe convince someone. And then I know this is to like you now, but yeah, so like overall, again, you can explain why there's discourse about evolution, look at how evolution works, and explain how they're related. Hopefully that would explain how, yeah, this works, and why there's so much discourse. So hopefully you now believe that evolution isn't this crazy thing that people come up with.